Hey learners, Jared here, and we're going to continue our discussion on rotating rigid bodies, and today we're going to focus on the energy of a rotating body. Now, we've talked about several types of energy before: potential energy due to elasticity and gravitational, and we've also talked about translational kinetic energy. That is the kinetic energy of an object that is moving linearly. But what about when you have an object that is moving but isn't actually translating anywhere, but it is rotating? How do you determine the kinetic energy of that? If you think about this object, at any point during its spin, if I freeze it, then all of those particles have some tangential velocity. That is a velocity that's tangent to their rotational path. And we have to add up every single particle's mass and then tangential velocity to get that kinetic energy. Well, we already kind of do that whenever we calculate the moment of inertia for an object. Now, the moment of inertia is how difficult it is to get an object to rotate or to change its rotation. It's no different than the linear mass of an object, how hard it is to linearly accelerate an object. The moment of inertia, is how hard it is to rotationally accelerate an object. Mass that is further out from your axis of rotation correlates directly to a larger moment of inertia. So to compute the kinetic energy of an object that is rotating, it comes out to 1/2 I omega squared, where I is your moment of inertia and omega is your angular velocity. And if you look at that, it's analogous to the translational kinetic energy, which is 1/2 mv squared. I is your rotational mass. How hard is it to get this object to change its rotation, i.e. starting it to rotate or stopping it? Changing the moment of inertia can change your rotational energy. For example, if you are rotating and you pull your mass in, you will start to spin faster. That is an increase in kinetic energy because kinetic energy is proportional to omega squared. A change in velocity is a greater change in kinetic energy overall. Just like a figure skater, when they pull their mass in, they start to rotate faster. But why does that happen? To answer that, we'll need to look at rotational momentum, which is what we're going to dive into next. Hope to see you there soon, and as always, keep learning.